So, what if I told you that eating like a massive heavy bowl of pasta at 9 o'clock at night will actually get you more sleep tonight?
I mean, it sounds great, right?
Yeah.
But the catch is, you will probably wake up feeling absolutely terrible anyway.
Yeah, exactly.
Right.
Which, sounds like a complete paradox at first.
It totally does. But it really highlights this massive blind spot in how we think about health and recovery in general.
Right. We spend, so much time obsessing over just the sheer number of hours we spend unconscious,
Right.
and we completely ignore the actual physiological quality of those hours.
Oh, absolutely. We treat the human body like a simple vending machine.
Oh, I love that analogy. Like you just put in a specific coin and get exactly what you want.
Exactly. You put in a cup of chamomile tea or, a warm glass of milk, and you expect a specific product to drop out at the bottom.
Right, in this case, 8 hours of uninterrupted blissful rest.
Yeah, or on the flip side, you drink an espresso at midnight and boom, you get insomnia.
Eat a massive turkey dinner, feel instantly sleepy. It's all very neat. It's a very comfortable illusion.
It is. Because we naturally crave that kind of immediate, predictable causality. We want a straight line between what we do and how we feel.
But human biology is just vastly more complex than a vending machine, right?
Vastly. Particularly when you look at the intersection of digestion and neurology. It's incredibly complex.
And for decades, the scientific data linking, what we actually put on our plates to what happens when we close our eyes has been incredibly murky.
Oh, so murky. We've basically been looking at this weird landscape of folklore, spotty human memories, and just a lot of conflicting advice from health blogs.
Which is exactly why we are doing a deep dive today into this massive brand new preprint study that, well, it really attempts to finally clear up that murky water for you.
It really does. And the data they're using is just phenomenal.
Yeah, it utilizes data from the Human Phenotype Project out in Israel, and the sheer scale of the data collection is just staggering.
Staggering is the right word. We're talking about nearly 4,800 person nights of data.
Wow.
Yeah, gathered from over 3,500 adults.
Yeah,
But the scale isn't even the best part.
right. It's the methodology. What I find so compelling is that they didn't just ask people, hey, how do you think you slept last night?
Exactly. Because people are terrible at remembering that stuff.
Totally. Instead, they combined real-time dietary logging apps with clinically validated wearables, these WatchPat wearable sleep monitors.
And that combination of technologies is really what elevates this whole thing from a guessing game to hard, actionable science.
Because historically, how did researchers even study this?
Well, historically, if they wanted to know how food affected sleep, they relied on these food frequency questionnaires.
Which are famously flawed.
Right, so flawed. They would literally ask someone, what did you eat last Tuesday? And then ask them to fill out a subjective sleep diary.
I can barely remember what I had for breakfast yesterday.
Right. Human memory is notoriously terrible, especially regarding portion sizes or the exact timing of when we eat things.
But with this study, we have precise timestamps of every single calorie consumed, right?
Exactly. Paired with objective, multi-stage physiological sleep data. We are actually looking at the biological blueprint of the night captured in real time.
And the mission of our deep dive today is to explore how this study cuts through all that noise to find the actual causal levers of sleep physiology.
Yes, we really want to know how the lunch you ate yesterday literally shapes your REM cycle tonight.
But before we get to the actual findings, I think we have to talk a bit more about the methodology.
We definitely do.
Because anyone who has ever tried a new diet or read a health article knows how confusing nutrition science gets.
Oh, it's a minefield.
Right. It's like, okay, let's unpack this. Trying to figure out if a single food, let's say broccoli, helps you sleep is like trying to figure out which specific instrument is out of tune in a massive symphony.
While you were wearing earplugs.
Yes. While wearing earplugs, there are simply too many variables happening at once. So how did the researchers actually know it was the broccoli that caused good sleep?
Right. And not just that, broccoli eaters happen to be less stressed or exercise more.
Exactly. Like, how do we know the broccoli actually did the heavy lifting?
Well, you are hitting on the fatal flaw of almost all observational nutrition epidemiology right there.
Which is what exactly?
You might read a headline stating that people who eat broccoli sleep better. But the reality is, the type of person who eats a lot of broccoli also happens to be someone who does yoga, has a lower baseline of stress, maybe goes to bed at a consistent hour.
Right. And perhaps they aren't drinking a pint of beer right before bed.
Exactly. Untangling the vegetable from the entire lifestyle is an incredibly difficult statistical knot to untie.
Which is where this specific study does something really brilliant. They used a machine learning technique called target trial emulation.
Yes, with a lag variable design.
Right. And I want to break this down because it's vital for you to understand why we can actually trust these numbers.
It's the core of the whole study.
So the model essentially looks at what they call day-end baselines, meaning it looks at what you ate and how you slept yesterday.
Where your immediate past.
Yeah, it feeds all your historical data, your typical sleep architecture, your habitual diet, your age, your body mass index. It feeds all of that into the system to establish your unique personal baseline.
Which is so cool.
It is. It's like the AI calculates your personal par for a golf course based on how you played yesterday. So it can see if this specific broccoli you ate today made you shoot above or below your own par.
I really love that golf analogy.
Yeah.
Because building on that, once the model has established your unique baseline, it moves to day n plus 1.
Okay, so the new day.
Exactly. It isolates the exact effect of the new day's food choices on that subsequent night's sleep. By mathematically adjusting for your immediate past, the researchers bring observational data as close as possible to a randomized clinical trial.
So they aren't comparing the, broccoli-eating yogi to the fast food-eating night owl.
Nope. They're comparing you to yourself, hour by hour.
But, with any machine learning model this complex, you have to test the radar, right? To make sure it isn't just seeing ghosts in the data.
Oh, absolutely. You need controls. And the researchers used both negative and positive controls.
And I love a good negative control. What did they actually do here?
They literally asked the model if daily dietary changes affected totally unrelated things, like whether a person slept on their left side.
Or if the food messed with the signal quality of the wearable device, right?
Because if the data suggests that eating a salad somehow causes you to sleep on your left side, we know the math is completely broken.
Makes total sense. So did it pass?
It passed the negative controls with 0 false positives. Diet did not affect those unrelated metrics at all.
Okay, so the AI isn't hallucinating. But a negative control only proves the model isn't making things up. They also had to prove it could catch real disruptions.
Which brings us to the positive control. They ran this using something universally understood by everyone: caffeine.
Ah, yes. The classic sleep killer.
Exactly. They asked the model to look at the interval between a person's last caffeinated drink and their bedtime.
And the radar lit up perfectly, didn't it?
It did. Just as clinical trials have shown for decades, the model caught that consuming caffeine closer to bedtime significantly shifted the user toward lighter sleep architecture.
And reduce their overall sleep efficiency. So we know the methodology is incredibly solid. It's sensitive enough to catch known sleep disruptors.
So with the methodology validated, we can confidently start looking at the actual levers we have control over every day.
Right. And the study divides these into 2 main categories, which I find really helpful: the timing of our meals and the actual composition of our meals.
The clock and the plate.
Exactly. Let's start with the clock, the timing, because most of us aren't chugging double espressos at midnight, but a huge percentage of us are eating dinner late due to, work schedules or social commitments.
It's incredibly common.
But when this model looked at meal timing, the numbers completely challenged my assumptions.
How so?
Well, a heavier, high-calorie evening meal actually increased total sleep time by an average of 7.7 minutes.
Which sounds like a win on paper.
Right. If I just read that single sentence, I would be firing up the stove at 9 p.m. every night to get extra sleep.
Wait. So a giant bowl of pasta right before bed gets me almost 8 extra minutes of sleep. Isn't more sleep always the goal?
And that brings us right back to the paradox we started with.
Yeah.
What's fascinating here is that, yes, you are technically unconscious for nearly 8 minutes longer, but duration is only one dimension of sleep.
Right. We can't forget quality.
Exactly. The physiological cost for those extra minutes is a higher mean sleeping heart rate, specifically an increase of about 0.73 beats per minute.
Okay, wait. And conversely, the study found that having an earlier dinner shortened total sleep time by about 12.4 minutes, but it significantly lowered the resting heart rate throughout the night.
Now, 0.73 beats per minute might not sound like a massive spike to someone just listening to those numbers. It sounds tiny.
It does sound small, yeah.
But if you wear a smartwatch or a fitness ring to bed, you have likely seen this exact phenomenon play out. You eat a huge, heavy meal, you go to sleep, and the next morning your recovery app is in the red.
warning you that your resting heart rate was elevated all night.
Exactly. Over the course of an 8-hour sleep cycle, that fraction of a beat translates to hundreds of extra heartbeats. Your body was basically running a mild marathon while you were unconscious.
Well, we have to remember that digestion is an intensely demanding metabolic workout. It's not passive.
Right, it takes real energy.
When you consume a heavy meal close to bedtime, your gastrointestinal tract requires substantial blood flow to break down that food.
Oh, wow.
Yeah, your liver's working overtime to process complex macronutrients. Your pancreas is releasing insulin to manage the influx of glucose.
A whole factory in there.
It really is. And the body literally generates heat to break down food, which fights the natural drop in core body temperature that is required to initiate deep sleep.
So it's actively working against the sleep process.
Exactly. All of this metabolic labor forces the sympathetic branch of your autonomic nervous system to stay highly engaged.
Okay, the sympathetic branch. That is the fight-or-flight system, right?
Yes, exactly. Or in this specific context, the digest and process system.
It is keeping the engine revved.
And when the sympathetic nervous system is active, your heart rate and blood pressure stay elevated. But the absolute hallmark of profound, highly restorative sleep is cardiovascular downregulation.
Meaning everything needs to slow down.
Right. It is the moment your parasympathetic nervous system, the rest and digest system, takes the wheel.
Ah, okay.
This allows your cardiovascular system to actually stop working and start healing from the stress of the waking day.
So those extra 7.7 minutes of sleep aren't a gift at all.
Not even a little bit.
Your body is basically keeping you sedated longer simply because it is trapped in the metabolic factory working the night shift. You might be asleep, but you are not truly resting.
That's a perfect way to put it.
So that covers the clock, right? And how timing dictates the workload we force on our heart. But let's look at the actual raw materials we're sending into that factory.
Of a plate.
Yes, the plate. Because the study found that what we actually put on our plate dictates the architectural blueprint of our sleep.
And the findings shift here from autonomic nervous system strain to the actual brain waves and sleep stages.
Which is fascinating.
It really is. And the most robust dietary findings in this entire massive data set center around one very specific thing: plant-forward diets.
Yeah.
And specifically, fiber density.
Yeah, looking at the numbers here, I was honestly blown away to see that fiber, something we almost exclusively associate with, bran flakes and basic digestion.
Right, keeping things moving.
Exactly. But it's actually the main driver for shifting our brain waves.
The numbers are incredible. Higher fiber density in the day's diet was linked to a 0.59 percentage point increase in deep sleep,
Wow.
a 0.76 percentage point increase in REM sleep, and a 1.35 percentage point drop in light sleep.
And all of this occurred alongside a massive 1.14 beat per minute drop in nocturnal heart rate.
Exactly. We often think of sleep as a single monolithic state, but it is highly dynamic.
Right, there are stages.
Yeah. Light sleep is what it sounds like.
Yeah.
It is transitional, it's easily interrupted, and it really doesn't offer deep physical recovery.
But deep sleep does.
Deep sleep is the critical window when your body gets to work on physical restoration. It repairs damaged tissue, builds bone and muscle, strengthens the immune system.
And then there's REM.
Right. REM sleep is your brain's cognitive and emotional processing center. It is where memory consolidation happens and where the brain essentially clears out the cognitive debris from the day.
So to synthesize this, here's where it gets really interesting. It is like fiber is the master architect that sneaks in while you are unconscious.
I like that.
It takes the basic, cheap blueprints of your light sleep, tears them up, and upgrades your night into luxury, high-end, deep, and REM sleep.
It's an architectural upgrade.
Exactly. It moves your time out of the low-yield light stages and invests it heavily into the high-yield restorative stages. And it does all this while simultaneously lowering the cardiovascular burden, acting as a brake pedal for your heart rate.
And the mechanism behind this architectural upgrade is deeply fascinating. It connects to an area of biology that is just exploding right now.
A gut-brain axis, right?
Yes, the gut-brain axis. Because when we consume complex fibers, our human cells don't actually digest them.
Oh, wait, really? We don't digest them?
No, we don't.
Yeah.
Instead, the diverse microbiome in our gut ferments these fibers.
Okay.
And this fermentation process produces these things called short-chain fatty acids, like butyrate.
Ah, butyrate. I've heard of that.
Yeah. These short-chain fatty acids act like chemical text messages. They
Right.
travel up the vagus nerve or circulate through the bloodstream, and they essentially tell the body to lower systemic inflammatory tone.
So they literally signal the brain that the environment is stable, safe, and primed for deep sleep architecture.
Exactly. That signaling is absolutely crucial because lowering systemic inflammation is a prerequisite for achieving extended periods of deep, slow-wave sleep.
But this brings us to a major realization about how we actually consume these nutrients. Because the researchers specifically checked if we could just, hack this system using isolated supplements.
Oh, right, because everyone wants a shortcut.
Totally. They looked to see if a person could achieve that same architectural upgrade by perfectly balancing their protein to carb ratio, or by simply taking a massive dose of vitamin C, folic acid, or magnesium in a vacuum.
And the data provides a resounding no to the supplement aisle.
Yeah, short-term, isolated macronutrients and micronutrients just do not pull the levers.
They really don't. I mean, the internet is constantly arguing about whether a low-carb or a high-carb diet is optimal for sleep.
Oh, it's exhausting. Or pushing magnesium pills as a cure-all.
Exactly. But according to the thousands of nights of data analyzed here, those isolated components don't move the needle in a statistically robust way when tested individually.
So what's the missing piece then?
It comes down to a concept discussed extensively in the research called the food matrix.
The food matrix.
Yes, nutrients in nature do not exist in isolation. They exist as a complex, interactive symphony.
Oh, right. Like we were talking about earlier with the instruments.
Right. When you eat a varied, plant-forward diet, you aren't just getting a single type of fiber. You are getting polyphenols, thousands of different fermentable substrates, and a specific physical cellular structure.
And that structure dictates how slowly sugars are absorbed into your bloodstream, right?
Exactly.
So swallowing a synthesized fiber gummy is fundamentally different from eating a massive, complex kale, quinoa, and chickpea salad.
Night and day difference. The gummy lacks the cellular structure and the diverse polyphenols that the gut microbiome needs to create that specific symphony of short-chain fatty acids.
It is the complex plant matrix, the actual diversity of whole foods playing together, that sends the right chemical text messages to your brain.
That's exactly right.
Well, we've covered a tremendous amount of complex biology today. I mean, from machine learning methodologies to autonomic downregulation and the gut-brain axis.
It is a lot to take in.
But the ultimate goal of target trial emulation is to provide actionable data. So let's bring this all back down to earth for you, listening right now.
What does this actually mean for your routine tonight?
Exactly. It means you have two distinct, highly actionable levers at your disposal every single day. Lever number one is the clock, the timing of your meals.
Right. If you've been waking up exhausted despite getting 8 hours of sleep, or your fitness tracker is showing a high nocturnal heart rate, you might want to look at that clock.
You might want to pull that dinner time an hour or two earlier, avoiding a heavy, high-calorie metabolic workload right before bed.
Just let your cardiovascular system actually rest.
Yeah. And lever number two is the plate, the composition of those meals.
If your goal is to upgrade the actual architectural quality of your sleep, securing more physical restoration in deep sleep and more cognitive processing in REM sleep, the data points clearly toward increasing your fiber density.
And expanding the diversity of whole plants in your daily diet. What I find so incredibly hopeful about this entire project is the accessibility of it.
It really is accessible.
Right. The researchers didn't ask people to adopt some extreme, punishing, impossible diet to see these benefits. They looked at realistic, median daily habits.
Simple, practical tweaks.
Yeah, like moving dinner slightly earlier, or swapping out a heavily processed side dish for a fiber-rich complex plant. Those make a measurable overnight difference in your sleep physiology.
You don't have to be perfect.
Mm.
You just have to gently shift the median of your habits.
It is a very empowering way to look at our daily choices.
It is. But as we synthesize all this data, I think there is one final crucial layer to consider.
Oh, what's that?
Well, this study, as massive and rigorously designed as it is, ultimately looked at averages. It showed us what happens to the average human physiology when these dietary levers are pulled.
Right, looking at the aggregate data.
But humans are highly beautifully individual. So this raises an important question. If these small dietary shifts affect the average person this significantly, how does your personal biology amplify or dampen these effects?
Oh, that is an interesting thought.
Because we all have distinct chronotypes. Whether you are naturally a night owl or an early bird, We have unique metabolic phenotypes that dictate how our specific bodies handle insulin and glucose.
Right, we aren't all wired exactly the same.
Exactly. So next time you eat a late dinner, ask yourself, is my body reacting the exact same way my neighbors would? Or is my internal clock playing by its own unique set of rules?
We know the livers exist now, but the calibration of those livers might be entirely unique to you.
I think that's something really important to mull over.
That is an incredible point to end on. We started this deep dive talking about that vending machine, the comfortable illusion that the body is just a simple input-output mechanism.
Right.
What this rigorous data from the Human Phenotype Project proves is that the machine isn't simple at all. It is a highly dynamic, complex symphony connecting your gut, your heart, and your brainwaves.
But the good news is, you are the conductor.
Yes, you are the conductor. You choose the tempo with your meal timing, and you choose the instruments with your fiber and plant diversity.
So experiment with your own dietary levers.
Exactly. Pay attention to how your specific body responds to the clock and the plate. Thank you for joining us on this deep dive, and here's to a better, more deeply restorative night of sleep.